So your first lesson on chapter 9, which is coordinate geometry of the circle. The first thing we're going to look at is the first learning outcome that is on the second slide. So it's find the equation of a circle with center 0, 0 and radius length r. So center 0, 0 is the origin. Okay, and I'll come back to the other learning outcomes later. So what is a circle? So just to give you a brief kind of background of what a circle is or what's weirded it, I suppose the whole idea of why we looked at coordinate geometry. And we mentioned before that coordinate geometry is used, I suppose, by pilots, and you can kind of see like, look, that's like a picture maybe of like maybe aircraft paths or something like that they might follow. So anyway, this will sound better than what I'm trying to explain. So the ancient Greeks believed that the circle was the perfect form because circular forms occurred so frequently in nature. They also taught that the stars and planets travelled in circular paths around the universe. Okay, so a circle is the set of all points in the plane, so you know your coordinate plane, that are equidistant from a fixed point, the centre. So the distance from the centre to any point on the circle is called the radius length of the circle, okay? So an interesting modern day application of coordinate geometry of the circle is the mapping of great circle routes. Like we can see below in the picture, New York, Moscow, Tokyo. A great circle of a sphere is a circle that runs along the surface of the sphere so as to cut it into two equal halves. As the Earth is almost spherical, we can draw imaginary great circles on the surface of the Earth. The shortest route between any 2 points on the surface of a sphere will lie along a great circle. This is why intercontinental airlines fly along great circle routes. It minimizes the distance they have to travel. Okay, so this is how it's used in everyday life when they're planning their map or planning their destination, say, and distance. On the map below, we can see the examples of 3 great circle routes: New York to Moscow, Moscow to Tokyo, and New York to Tokyo. Okay? So, what do you mean by a circle with center 0, 0 and radius length r? Basically, it means that the center of the circle lies on the origin. When it mentions that the center of the circle is 0, 0, then straight away the formula for that circle, or the equation, not even the formula, sorry, the equation of that circle is x squared plus y squared is equal to r squared. Okay? So, an example would be, find the equation of the circle, firstly, part 1, with center 0, 0 and radius length 9. So the first thing you put down is your formula, which is x squared plus y squared is equal to r squared. It's the formula, but also it's the equation of the circle. We're also given that r is equal to 9. So all we do is put 9 in for r squared. We get x squared plus y squared is equal to 9 squared. We get x squared plus y squared is equal to 81. And that's your equation of the circle with center 0, 0 that passes through. Sorry, that's center 0, 0 and that has a radius length of 9, say. Okay, so it'll be basically saying that the distance out from 0, 0 to the edge of the circle would be 9 units. Okay, another one. Find the equation of the circle with center 0, 0 and that contains the point 2, 3. Okay, for this one here, it's slightly different, right? We know that it's center 0, 0, so straight away we know that it is the equation x squared plus y squared is equal to r squared, okay, up here. But we don't know the radius, okay? But what we are told is that it contains the 0.23. What that means is that the 0.23 is on the circle. So you know from your knowledge of like circles and geometry from junior cert and even your area and volume, that the distance from the centre to the edge of the circle is always equal to the radius. So couldn't we use our distance formula here? So the first thing is we work out the radius using our distance formula. So mark this x1, y1, mark this x2, y2. Okay, plug it into your distance formula, which you remember from coordinate geometry of the line. We get a radius then of 13, square root of 13, sorry. Okay, so now what we have is, we have the center of the circle being 0, 0. We now have the radius length being square root of 13, and we plug it into our formula for the equation of a circle with center 0, 0. So which is x squared plus y squared is equal to r squared. R is equal to square root of 13. Remember, when you square a square root, it disappears. So we have x squared plus y squared is equal to 13 being our equation. Okay. Another way that you could be asked about finding the equation of a circle with centre 0, 0 is when you're given a circle like here and you have a line that's drawn to the circle. So remember, a line that's drawn or touches off a circle at one point is a tangent. The centre here, the distance from that centre to that line is equal to the radius, okay? And it also forms a right angle here because it's like perpendicular. So if we are given the centre and the equation of a tangent to the circle, then the radius is found by getting the length of the perpendicular from the centre of the circle to the tangent. Okay, so basically what they're saying is that if you are given, right, this point here, and you're just given the equation, right? Firstly, to get the length of the radius, wouldn't you kind of need 2 points or 2 sets of coordinates? If you didn't have a coordinate on this line here, yes, you could go and find one, but what would be easier then is to use your perpendicular distance formula. So find the perpendicular distance from this point to this line, and that would give you the length of the radius. Okay, so this is kind of like this question here then, an example. So the line 2x plus 3y minus 13 is equal to 0 is a tangent to a circle with centre 0, 0. Find the equation of the circle, right? So they just do a little sketch. Like, you can do a sketch, you can mark them in if you want, but remember the origin is 0, 0, that's the centre of the circle. So if you got your compass and put it here and placed it all the way around and drew your circle, you'd have it fairly even, right? Or drawn accurately, should I say, not even. We're told that there is a line which touches off the circle at one point, so that's called a tangent. We have the equation of that line. So don't we know that, right? How do I get the radius from here to here? I don't have a set of coordinates on that point, but I do have the equation of a line. So I can think of my formula then. So the radius of the circle is the perpendicular distance from 0, 0 to that line. Okay, so using the formula then, we have ax1 plus by1 plus c, all divided by square root of a squared plus b squared. Okay, and just sub in, you have a to be 2, you have b to be 3, you have c to be minus 13, and you have x1 to be 0, y1 to be 0, and plug it in. So that comes out then to be the square root of 13. Now remember what the question asks you. It asks you for the equation of this circle. So it does have centre 0, 0, so straight away the equation of the circle is x squared plus y squared is equal to r squared. R is equal to square root of 13, which you found. Now, if you left it at 13 over the square root of 13, it will still work out for you. But once you put that into your calculator, or remember how they kind of simplify that into the square root of 13 is, do you know when you have surds, you multiply the top and the bottom by the conjugate. Or sorry, you multiply the top and the bottom by the square root of 13. So you'd have 13 times square root of 13, square root of 13 times square root of 13, which will give you 13. That will cancel with that and leave you with square root of 13. So remember, that's like rationalising the denominator. So that's how they simplify to the square root of 13, and you can easily do that. Sometimes the calculator does that work for you. So therefore, we have the radius to be equal to the square root of 13. Plug it into our equation of the circle with centre 0, 0 being x squared plus y squared is equal to 13. And square root of 13, all in brackets to be squared, will mean that the square root will be gone, and that'll leave you with x squared plus y squared is equal to 13. Then it says, just to give you a little extra note here, sorry, I'll just kind of pull this back. Finding the radius of a circle from its equation, okay? So the circle whose equation is x squared plus y squared is equal to r squared will always have centre 0 and radius r. So say the circle x squared plus y squared is equal to 8 has centre 0, 0 and radius square root 8, okay? How did we get square root 8? We literally put x squared plus y squared is equal to r squared underneath this. If it asked you for the radius, you'd say r squared is equal to 8, so r is equal to the square root of 8. Then this one here, look. If the equation of the circle is 4x squared plus 4y squared is equal to 9, then like if it asked you, right, it gave you that in that format, and it asks you for the radius mostly, because it's going to be the centre is going to be 0, 0. Now at the moment it's not in the form x squared plus y squared is equal to r squared. It's in the form 4x squared plus 4y squared is equal to 9. So you divide across each term by 4. So divide across by 4, that will leave you with x squared plus y squared is equal to 9 over 4. So therefore, now what we'd write underneath that is x squared plus y squared is equal to r squared. You'd be saying r squared is equal to 9 over 4. You'd be saying r then is equal to square root of 9 over 4, which will come out to be 3 over 2. Okay, so that's actually reading the radius from the equation of a circle. So up until now, I'd like you to take down those examples, right? So you've 1, 2, you could take down that point as well, and that example, and actually take down those 2 examples there. So these 3 questions then I'd like you to try after that. So the first one, find the equation of the circle 0, 0 if the line 4x minus 3y minus 25 is equal to 0 is a tangent to it. So that's very like the example that I did, the third example. Question 9 then, the line 3x minus y plus 10 is equal to 0 is a tangent to the circle with centre 0, 0. Find the equation of the circle. Grand, okay, so that's asking you for the equation of a circle again. The next one then, find the equation of the circle S with centre 0, 0 and radius 2 root 5. Okay, so we have the radius length. That's grand, we can simply just put that down because once we know that the centre is 0, 0, the equation of the circle is x squared plus y squared is equal to r squared. Then it says T is a line x minus 2y plus 10 is equal to 0. By finding the distance from the centre of S to T, determine whether T is a tangent to S. Right, so this is kind of getting you to confirm whether the perpendicular distance from the centre to that line should be equal to the radius length. If it's not equal to the radius length, then it's not touching the circle. Because if you can see over here, look, a line is a tangent to a circle if the perpendicular distance from the centre of the circle to the line is equal to the radius length. If it's not touching off the line, it's a little bit away, then it's obviously the distance from the centre, right? So the distance from the centre to that line would be greater maybe than the radius, or if it was like a line going through here, be less than it. So what you're confirming from that question is that the distance, perpendicular distance, and it is perpendicular because these create perpendicular lines, perpendicular distance from this centre here to that line should be equal to the radius. Okay, and I'm going to give you a few other questions then after out of the book after that. Okay.